Hi all. So I just want to make this very quick video, very quick, I promise, based upon the last video on the mass spring problem. And the previous video was quite long, but I think, well, I don't think, I know that there's a proof to it and there's a quicker way to do it. So I just want to take the time in this video to briefly go over part C of the question again. Given that we already know part A where k equals 4/3, and we already know part B, which was, I think, 5/3 g meters per second squared. But in order to find the maximum speed attained by P as it moves from A to B, we can also use this general force balance equation, which is very applicable to SHM, that is simple harmonic motion. Now I've got the general force balance equation written here, mx dot dot, where x dot dot is simply the second derivative with respect to time of displacement, so that's going to be acceleration right there, and that's going to be equal to the tension and the weight of the mass. Now beware the negative sign here. This doesn't necessarily mean that the tension is losing or something. It simply means that the tension is orientated in a different direction or an opposite direction to the weight of the object. Okay. So if we write this out to illustrate what's going on in the actual question, where we have a mass hanging from a ceiling connected to a spring. So there's my spring, which I'm just going to model as a straight line. There's our mass P. And this entire distance is 3a. This entire distance is 3a. The original length of the spring is a, such that the distance between the original length and point A is going to be 2a. So that's going to be point A. And then point B is going to be over here, where the question says that the distance between the ceiling and point B is half A. And then the ceiling here is O. So OA, so from O to A is half A. From O to B is half A, small a. From O to A is going to be 3a. The original length of the spring is a. At rest, point B is held at point A. So sorry, particle P is held at point A and then released. So without further ado, let's rewrite this generic force balance equation to illustrate this particle here. And that's simply going to be equal to mg minus kmg x minus a over a equals m d2x over dt squared. Now, I've chosen, rather than extension here, rather than simply writing E in this tension. So this is tension, right? I've simply written the extension as a function of the distance from the ceiling. So x is the distance from the ceiling. Spelled ceiling wrong. And allows us to write the extension as its function. So the extension effectively is based upon our distance from the ceiling. So if we go half a, we put half a into there, and then clearly the extension is minus half a, which makes sense because we've squashed the spring to a distance of half a. It makes sense. Okay. So we are going to label this equation 1, and then equation 2 is simply going to be equation 1 multiplied by dx over dt. Okay, where dx over dt, okay, the first derivative of displacement, equals v. Now you need to remember that we have force here. In mechanics or physics, power equals force times velocity. It's very important that we just keep that at the back of our minds. So this means we are going to get an expression mg dx over dt minus k mg x minus a over a equals m d2x, forgot my dx over dt there, equals m d2x over dt squared multiplied by dx over dt. So this is going to be my equation number 2. So the next thing we're going to do is that we are going to integrate expression number 2 with respect to time. Now, before we do that, we need to set some conditions because we're obviously going to integrate with respect to time between some interval, okay? And we're going to choose to integrate between t equals 0 and t equals some arbitrary value t further on. And we need to realize that at t equals 0, x equals 3a. Okay, so at the beginning of time, if we read the question, at the beginning of time, the particle is held at rest at a, where a is a distance 3a from the ceiling. So x equals 3a. And then at t equals t, x simply equals an arbitrary value of x along the distance to the ceiling. Okay, so effectively those are going to be our intervals, which means that we can integrate each of these and simply plug in our values of x. So if I color code these, so color code that yellow, color code that one orange, and color code this one blue. We'll do them step by step. So mg dx over dt integrated is going to give me mgx, but I need to put my limits at the allotted times, where at t equals 0, my first limit, x equals 3a, and at t equals t, my second limit, x equals x. And that's simply going to give me mg x minus mg 3a, which is going to give me mg x minus 3a, which is simple enough. The next one, kmg x minus a over a. I'm going to ignore this kmg because that's just a constant. I'm just going to focus on this x minus a over a. So x minus a over a dx by dt is the same thing as x over a minus 1 dx over dt. When we integrate that, we are going to get x squared 2a minus x. And we need to put that between the limits of, again, x and 3a. So when we do that, we end up getting x squared over 2a minus x, take away 3a squared over 2a minus 3a. So our expression therefore becomes, once I do the arithmetic and I rationalize the denominators, so I make the denominators the same, I'm left with x squared over 2a minus 2ax over 2a minus 9a squared over 2a plus 6a squared over 2a. When I put all these together and put back the kmg, I'm left with kmg x squared of, well, x squared minus 2ax minus 3a squared over 2a. For my last one, the right hand side, remember we said that dx over dt equals v. That means I can change both differentials to be functions of v. So m d2x over dt squared dx over dt is also equal to mv dv over dt. The second differential of displacement is equal to the first differential of velocity. And this is simply an integral in v. So integrated, that's going to be mv squared half. So kinetic energy, basically. And what you end up getting is that when you integrate p with respect to time, you get energy. So we're left with equation 3, which is our energy balance equation. So our energy balance equation should be mg x minus 3a minus kmg x squared minus 2ax minus 3a over 2a equals half mv squared. Okay. So what do we do with this? Well, if we're trying to find out the maximum speed attained by p as it moves from A to B, we still have to remember that the maximum speed occurs when the particle reaches its equilibrium point. Okay, so all of that concept is no different from the last video. So max speed reached at equilibrium point. From the last video, we calculated the equilibrium point as being, I think it was 5/4a from ceiling. So the equilibrium point is 5 over 4a. Now, let me just check back my notes just to make sure that... No, that's wrong. That's the amplitude. So the equilibrium point is 7/4 a. My bad, 7/4 a. So let me just remove that. 7/4 a. So the equilibrium point is 7/4 a from the ceiling. So 7 over 4a in this case equals x. And then we plug that into here, we rearrange, and we should get v again. Remembering also that k equals 4/3. Okay, so when we plug in 7 over a into our equation here, so mg 7 over 4a minus 3a minus 4/3 mg 49 over 16a minus 2a 7 over 4a minus 3a over 2a equals half mv squared. So we have some cleaning up to do. Now I'm not gonna do all of this in my head. So I'm just going to use my calculator. So 7 over 4 minus 3 gives me minus 5 over 4. So minus 5 over 4 a mg. Take away 4/3 mg. So 49 over 16. Take away 14 over 4. Take away 3, all divided by 2, gives me 55 over 32a. Equals half mv squared. I'm going to get rid of my m's because they appear on all sides, so it's redundant. So I'm left with 55 over 32 plus 5 over 4. Actually, that's wrong because I neglected this 4 over 3. So 55 over 32 times 4 over 3 plus, or take away rather, take away 5 over 4. And that's going to give me 25 over 24ag equals half v squared divided by 2. Sorry, multiply it by 2. And we get 25 over 16 ag square rooted equals v. And does that fall in line with our previous answer? 25 over 16 ag equals v. Wait, what did I say it was? Sorry, 25 over 12. Yep. Duh. 25 over 12. And they are the same thing.